Hey everyone, and welcome. Today, we're going to tackle one of the absolute biggest ideas in all of programming, classes and objects. You might not even realize it, but this is the magic behind pretty much everything, from your favorite video games to the apps on your phone. So how does it all work? Let's dive in. So let's put you in the driver's seat for a second. Imagine you're building this awesome website, and it's full of these cool virtual robots. Each one is totally unique, right? It's got a name, a different color, a specific weight, but they all kind of share the same basic structure. How in the world do you keep track of all that data without your code becoming a total spaghetti monster?
All right, to get our heads around this, let's meet our first two digital employees, Tom and Jerry.
Okay, so check this out. We've got Tom, he's the red one, weighs 30 pounds. And then there's Jerry, who's blue and a little heftier at 40 pounds. Now here's the key thing to notice. Their details, what we call properties, are totally different. But look, they can both do the same action. They can both introduce themselves. And that's the puzzle we've got to solve, how to handle this mix of unique data and shared actions. Okay, let's just focus on Tom for a second. We've got his name, his color, his weight. All this info is just kind of floating around. So what's our first big challenge? Yeah, how do we wrap all of that up into one single tidy package in our code? And the answer to that, the first key piece of our puzzle, is something called an object. So what is an object? Honestly, it's pretty much what it sounds like. Think of it like a digital box or a container. You can stuff all the related data in there. We call those properties or attributes, and you can also put in all the actions it can do, which we call methods. The most important thing to remember is that an object represents just one specific thing. Not robots in general, but one individual robot. So let's see what this looks like for our buddy Tom. We'd create an object, we'd plug in his specific values, Tom for the name, red for the color, 30 for the weight, and we'd also include that introduce self action. Boom! Everything about Tom is now perfectly organized in one single unit. Awesome, right? Problem solved for Tom. So naturally, we just do the exact same thing for Jerry. We make another object, fill in his details, but hang on a minute. Do you see what's happening here? We're repeating ourselves. The structure of Jerry's object is a carbon copy of Tom's. Now imagine we had 100 robots, or 1,000. We'd be writing out that same structure over and over again. That is not a good use of our time. So, all that repetition tells us there has to be a smarter way to do this, a much more elegant solution. And that solution, my friends, is called a class. Okay, so what is a class? The absolute best way to think about it is like a blueprint for a house. The blueprint lays out the plan, right? It says the house will have 3 bedrooms, 2 bathrooms, and a kitchen. But it doesn't say what color the paint will be or if you're going to put a comfy couch in the living room. That comes later. A class is exactly like that for our code. It's the template that defines the structure, but it doesn't hold any of the specific real-world data itself. And here it is. This is our robot class, our official blueprint. Now, look closely. It lists the properties, name, color, weight. But see, there are no actual values like Tom or red. Instead, it just defines what kind of data will go there. The name will be text or a string, the weight will be a number, an integer, and it also includes the introduce self method, that shared action. This is the reusable template we can now use to build any robot we want. Okay, the blueprint is designed. Now for the fun part. Let's head over to the assembly line and see how we actually use this robot class to build our individual robot objects. So here's how it would go. First, we've got our robot class, our blueprint, all ready to go. Next, we use that blueprint to basically stamp out a new empty robot shell. And then in a third step, we have to go in and manually fill in the blanks. We'd say, okay, for this one, the name is Tom, the color is red, and so on. It works, for sure, but it still feels a little clunky, doesn't it? It's a few too many steps. Which, of course, leads to the next logical question. Can we do better? Is there a way to streamline this whole thing, to build the robot and set it up with all its unique details in one single, elegant move? Oh, you bet there is. And this is where the constructor comes into play. A constructor is this really special method that lives inside the class, and its one and only job is to create and set up an object all at once. It's the factory assembly line of programming. You put the parts in one end, and a fully built product comes out the other. And this right here shows you the difference in a nutshell. It's night and day.
On the left, that's the old way, building the empty shell, then adding the name, then adding the color, piece by piece. But look at the right. That's the power of the constructor. We just say, I want a new robot, and we hand over all the specs. Tom, red, 30, all at once. And in one clean line of code, a fully formed, ready-to-go robot object pops out. It's so much cleaner, way more efficient, and you're way less likely to make a mistake.
All right, we've covered a lot of ground. So when you boil it all down, what's the one thing you absolutely need to remember from all this? It's this simple idea right here. A class is the blueprint, it's the template, the plan. An object is the actual thing you build from that blueprint. It's the instance. Getting this difference is everything. It's what lets programmers build massive, complex applications in a way that's organized, reusable, and easy to manage. And think about it, this idea of a blueprint and an instance goes way beyond just robots. You could have a blueprint for a user on a website, a product in a store, a character in a game, literally anything. You now have the fundamental pattern for modeling pretty much anything you can imagine in code.